Alright, so now let's understand this problem. So over here we are given an array and a number k. And what we need to do is, we need to find the k most frequent elements from this array. So for example, if our input is this, right, and k's value is 2, it means we need to find top 2 elements from this array which appears most number of times. And so the output over here should be 1, 2, because if you see 1 and 2 both appear 4 times each, right, which is the highest frequency. But now the twist over here is that we actually need to do it efficiently with a time complexity which is better than order of n log n, right? So that's a hard requirement of this particular problem, right? That's our entire problem. Now maybe let's look how we can solve it. So now to solve this problem, what we will do is, first of all, we will create a hash map to essentially count how many times each number appears. So we will go through every element in this input array, and for every element in the array, we will add 1 to its count in the hash map. So let's maybe start iterating through this array and understand. So at index 0, element is 1, and right now if you see, it is not a part of the hash map. So we add 1 to the hash map with a count of 1. Now at index 1, element is 2. Again we add 2 with count 1, right? At index 2, element is 1 again. So we increment its count to 2. Now at index 3, element is 2. So we increment its count to 2. At index 4, element is 1 again. So we increment its count to 3 now. At index 5, element is 2. Again we increment the count for 2 in the hash map to 3. At index 6, element is 6. So we add it with a count of 1. Now at index 7, element is 1. So we increment its count to 4. At index 8, element is 3. So we increment its count to 2. And finally at index 9, element is 2. So we increment count of 2 to 4. So finally our frequency map looks like this. So now we know how many times each number appeared in the input array, right? Now if you see, we need to track the top key elements from this frequency hash map with most frequencies, right? And to do this, the most obvious method that comes in our mind is by sorting the values in the hash map by their respective frequencies, right? And once these numbers are sorted by their frequencies in descending order, we can quickly pick the first k elements as our result. But sorting all the numbers would be inefficient over here and would be of order of n log n complexity. So we will instead make use of a min heap of size k over here to track the top k frequent elements, right? So the intuition over here is that we use a min heap as it helps us efficiently maintain only top k frequent elements. Because whenever the heap size exceeds k, we quickly remove the smallest element, as checking the minimum in the heap only takes order of 1 time, right? And popping it while maintaining the heap property will be order of log k, right? So this ensures we never sort all the elements, keeping the process fast and space efficient. So what we do is, we go through each num, frequency pair in our map one by one. And now since we want to get the top k elements by their frequencies, while pushing these pairs into the min heap, we would simply reverse their order to frequency, num instead of num, frequency, right? So now the heap would actually use the frequency to sort them instead of the value of the number itself, right? So in this example, firstly we will push 4, 1 into the heap, where 4 is the frequency of 1 in the input array. So the current heap is 4, 1, right? Next, we push 4, 2. So heap now is this, right? And its size is 2. And then we push 2, 3. And now since the size has become 3, which is greater than k, we will pop the smallest frequency element, right? So we simply pop 2, 3 out because 3 over here appears least frequently. So finally, heap remains 4, 1 and 4, 2, which means our top 2 frequent elements are 1 and 2, right? So our final answer is 1, 2, because both 1 and 2 are the most frequent elements appearing 4 times each. right? So that's the entire solution. I hope you got it well as to why we are using a min heap over here and why we need to reverse the num comma frequency to frequency comma num while pushing each pair from the hash map into the heap, right? Now maybe let's see the code for this. So first of all, we start by importing the heap queue module. And this is the Python's built-in library for working with heaps or priority queues, right? And we will use heaps to efficiently keep track of the top k elements. Next, we define our function top k frequent, which takes two inputs, a list of numbers called nums and an integer k, representing how many top frequent elements we want to find. Now we initialize an empty dictionary called frequency_map, and this will store each unique number from the array as a key and its frequency or the number of times it appears as the value. Now we start a loop that goes through every number present in the nums list, and for each number we increase its count in the frequency map, right? And here this particular line, get num, 0, checks if the number already exists in the hash map. If it does, we get its current frequency. Otherwise, we take 0 as the default and add 1, right? And this way we build our frequency table efficiently. Now, after counting the frequencies, we create an empty list called min_heap, and this will act as our min heap, meaning the smallest frequency element will always stay at the top. Now we loop through each key value pair in our frequency map, that is every unique number along with its frequency. And for each number, we push a tuple frequency, num into our heap. And since Python's heap queue creates a min heap by default, the heap will be ordered based on the frequency. The smallest frequency element will come first. Now after each insertion, we check if the heap size exceeds k. If it does, that means we currently have more than k elements inside it. So to maintain only the top k frequent elements, we remove the smallest frequency element using heap pop. And this ensures that at any point, our heap contains only k numbers with the highest frequencies. Finally, we extract just the numbers from the heap and return them as a list, because each entry in the heap is a tuple with frequency, number. So we take only the number part from each tuple, right? And this gives us the list of top k frequent elements. So that's the entire implementation of this solution. Now maybe let's talk about its efficiency. Now building the frequency map takes order of n time, right? And then each heap operation is order of log k, which is done n times over each number in the hash map. So total time complexity over here will be order of n log k, right? And space complexity for this will be order of n because we are using an extra hash map and a heap. So that's our full solution. I hope you understood it well. And now I will see you in the next one.